Welcome to the interview room where we decode the secrets to acing data science interviews. I'm Chitti, your interview guide. Here's the secret. 80% of interview questions aren't testing your knowledge, they're testing your thinking. Can you break down problems? Can you communicate uncertainty? Can you admit what you don't know? Today, we watch Peter walk into an interview with Tony. Let's begin.
Explain linear regression and what its basic assumptions are.
Option 1, formulas. Option 2, assumptions and thinking.
Linear regression uses the equation y equals mx plus b. It fits a line through data points to minimize squared residuals using the least squares method.
Peter recited a formula. He sounds technical, impressive even. But Tony is thinking,
He knows the math, but does he understand it? Can he simplify? Does he really get the assumptions?
this is how you need to answer. Linear regression finds the best straight line through data to predict continuous values. Let me give you a concrete example. Predicting house prices based on square footage. The algorithm draws a line that minimizes prediction errors. It reduces the gap between what we predict and reality. But here's the critical part. Linear regression makes 4 key assumptions. Assumption 1, linear relationship. The relationship between input and output must be linear. If the data follows a curve, linear regression will underfit and give poor predictions. That's when I'd consider polynomial regression or decision trees instead. Assumption 2, independence of observations. Each data point should be independent of others. If I'm predicting stock prices where yesterday's price directly affects today's prediction, the observations are not independent. In that case, I use a model that matches the data's dependency structure, such as a time series model. Assumption 3, homoscedasticity. The spread of errors should be uniform across all prediction ranges. Imagine predicting house prices. The prediction errors shouldn't be huge for expensive houses and tiny for cheap ones. If they are, the model is biased and violates this assumption. Assumption 4, normality of residuals. The errors or residuals should follow a normal distribution. If they don't, the model's confidence intervals and statistical tests become unreliable. So before I build the model, I validate all these assumptions. If relationship isn't linear, polynomial regression or decision trees. If data isn't independent, time series models. If variance is uneven, different algorithm entirely. If residuals aren't normal, transform the data or use robust regression. Most candidates fail because they confuse knowledge with understanding. Knowledge is reciting. Understanding is explaining why it works and when it breaks.